In this video, we're going to be focusing on how to determine if a given molecule is ionic or not ionic based on whether it's a metal bonded to a nonmetal or some other variation. So we know that ionic bonds are bonds between a metal and a nonmetal in most cases. But what happens if we have a metalloid? Recall that metalloids have properties of both metals and nonmetals. Sometimes they have properties more similar to metals, and sometimes they have properties more similar to nonmetals. So what's going to happen if they're part of a bond? Do we count it as a metal? Do we count it as a nonmetal? Or is it just never ever going to be an ionic bond because my ionic bonds are specifically between a metal and a nonmetal? Well, we're going to keep in mind that something about metalloids is that in bonds, they typically behave more like nonmetals. So what we're going to do is we're just going to treat metalloids as if they were nonmetals in this sense. So if I have a metalloid, so let's think of an example. So if I have silicon tetrachloride, SiCl4, and let's draw that out to see what it looks like. We have silicon with chlorine, and we've got 4 chlorines. Tetra means 4. We'll learn about naming later on. All right, so we want to know if this bond right here is an ionic bond or some other type of bond. And we could do a couple different things. We could say, well, let's say we look at the electronegativity. That's what we did in the last video. So we say chlorine has a value of 3.0, and then silicon has a value of 1.8. And we could totally subtract 3.0 minus 1.8, and we would get 1.2. And that would tell us right there that it's not an ionic bond because 1.2 is less than 1.8. But we could also look at whether these are metals, whether it's a metal bonded to a nonmetal or something else. And we have silicon, which is a metalloid. Remember, this staircase elements, the ones separating the metals and nonmetals, those are metalloids. Silicon is a metalloid. But we just said that we are going to treat metalloids as if they are nonmetals. So pretend like this is a nonmetal, and then chlorine we already know is a nonmetal. So nonmetal bonded to a nonmetal, that's not an ionic bond. That would be a covalent bond, which we'll learn about later. But metals, ionic bonds are when a metal bonds to a nonmetal, and here we do not have a metal bonded to a nonmetal. So for 2 reasons, we could so the electronegativity, but also we have a nonmetal bonded to a metalloid. So think of it like a nonmetal. Think of it like a nonmetal bonded to a nonmetal. And both of those tell us that this is not an ionic bond. So actually I can keep that on there. All right, so for multiple reasons, we know that this is not an ionic bond. So something else that I want to touch on in this video is that an ionic bond is a bond between 2 ions. That's literally where it gets its name. Ionic bond is a bond between 2 ions. So if something is not an ion, that means it's not going to be part of an ionic bond. Ionic bonds are made up of an ion bonded to another ion. So, you might recall that we talked about certain elements do not form ions. And maybe I should have used the term do not instead of cannot. I'll change that later. But you can make anything happen through a lab, whatever, but do not typically form ions. So our noble gases, we know that they are happy with 8 valence electrons. So they are not going to form ions. And then these elements, they kind of can form ions, but they typically don't. So any elements in this column right here, what is that, column 4 or column 8, group 4 or group 8, we know that they, if we have an element in one of these columns and they are part of a bond, they are not going to be part of an ionic bond. So if there's an element in, well, these elements right here, the noble gases, we know that they're just not going to form bonds. So we can just cross those out from the get-go. But then these elements right here, they're unlikely to form ions. And if you can't form an ion, then you're not going to form an ionic bond. So any element here, we're going to say, is not going to be part of an ionic bond. They're going to be, if they form a bond, they're going to be part of some other type of bond, probably a covalent bond, which we'll cover next. So that's just another thing that will be important. Will be really important going forward, because later on we're going to be talking about polyatomic ions, and where we might have an ionic bond between two nonmetals. Kind of. We have a polyatomic ion where, let's say we have like NH4 1+, and we could do chlorine again, so chloride. So chlorine 1-, and these could form a bond, and we get NH4Cl, and we get and it forms a bond, and it's an ionic bond, and even though we don't have a metal here, we have two ions. And the most important thing with an ionic bond is it's a bond between two ions. I would say that's the most important characteristic. The only exceptions where we're not going to have a metal bonded to a nonmetal are if we are using polyatomic ions, which we will learn about later. And those are just a group of atoms together that form an ion. So if they form an ion, that's going to be one of the most important things, because an ionic bond is a bond between two ions. So more on that later. That's probably really confusing at this point in time because we don't know what a polyatomic ion is. But later on when we get to it, it'll make a lot more sense. That will be part of the exception. And this point right here is probably one of the most important points, that an ionic bond is a bond between two ions.